Hello students, welcome to the online lecture series of Basics of Computer Network. Myself, Assistant Professor Mr. V.R. Wadekar from Matoshi College of Engineering and Research Center, Nasik. Today, we are moving to the end of this unit third, that is multi-access mechanism and standard Ethernets. Now, before starting our today's topics, let's have a quick revision. Now, guys, in last lecture, we have seen the categories of standard Ethernet. That is your 10 base T, 10 base 5, 10 base F, 10 base T. Then we have seen what are the characteristics of each category. Then, before moving to the fast Ethernet and gigabit Ethernet, we have seen what are the modifications, changes that made in a standard Ethernet by using a bridge. Because bridge, it is going to raise the bandwidth as well as it is also going to separate the collision domain. After that, we have seen switch Ethernet, full duplex Ethernet. Now today, we are going to study fast Ethernet, gigabit Ethernet and 10 gigabit Ethernet. And then we are going to see IEEE 802.4 and 802.5 project. So guys, today we are going to talk about fast Ethernet. In the 1990s, some LAN technologies with transmission rate higher than 10 Mbps, such as your fiber channel or FDDI, they appeared on the market. And if the standard Ethernet wanted to survive, it had to compete with these technologies. So Ethernet, it made a big jump by increasing its transmission rate up to 100 Mbps, and the new generation was called fast Ethernet. And hence, fast Ethernet, it was designed to compete with LAN protocols such as fiber channel, FDDI, and it created fast Ethernet under the name 802.3U. And it is a backward compatible with standard Ethernet. It means it can also communicate with your standard Ethernet, and it can transmit the data rate that is 10 times faster at a rate of 100 Mbps. Now, what are the goals of fast Ethernet? First, to upgrade the data rate to 10 Mbps from to 100 Mbps from 10 Mbps, and then make it compatible with standard Ethernet. Third, keeping the same physical address, that is 48-bit address, and keeping the same frame format. A new feature, guys, added to this fast Ethernet, which is called as what? Auto negotiation. Now, auto negotiation, it allows two devices to negotiate the mode or the data rate of operation. And it was designed particularly to allow incompatible devices to connect to one another. For example, a device, with a maximum capacity of 10 Mbps, it can communicate with a device with 100 MB capacity. And to allow a station to check hub's capability and also to have a multiple capabilities. Now, to be able to handle 100 Mbps data rate, several changes need to be made at your physical layer. So basically, if we talk about the topology, fast Ethernet, it is designed to connect two or more stations. And suppose if there are only two stations, then these two stations can be connected point to point. Or there are three or more stations are there, they need to be connected in what? Star topology using switch or hub. Now talking about the encoding. Now Manchester encoding it needs 200 megabaud bandwidth for a data rate of 100 mbps, and which makes it very unsuitable for a medium such as your twisted pair cable. And for this reason, few alternatives it has been done, and those alternatives in that the encoding and decoding scheme it was adopted. But using only one scheme, it is not going to perform equally well for these three implementation, that is 100 base TX, 100 base FX, and 100 base T4. So we have used a different encoding for each of this implementation. So talking about this 100 base TX. Now we are going to talking about what 100 base TX. It uses a pair of twisted pair cable, either category it is a 5 or STP. And for this implementation, guys, we have used MLT3 encoding. But this encoding, it is not a self-synchronous line coding scheme. So for that purpose, in order to avoid this problem, we have used 4B, 5B encoding scheme. That is a block coding, in order to provide a bit synchronization by preventing the occurrence of long sequence of zeros and ones, which makes the data rate 125 mbps, and then it is fed to this MLT3 encoding system. Now talking about this 100 base FX, so it is going to use a two pairs of fiber optic cables, and fiber optic cable it can easily handle high bandwidth requirement by using simple encoding schemes. So we use NRZ I encoding over here. But as you know that NRZ I encoding it doesn't provide bit synchronization for long sequence of zeros and one. So to overcome this problem, we use same, that is 4B 5B block encoding scheme. After that one, the third implementation it was 100 base T4. Because guys 100 base TX it can provide a data rate 100 mbps, but it requires the use of cat5 cable or shielded twisted pair cable. So this is not cost efficient for those areas premises that have already been wired with this UTP category 3 cable. So a new standard which is called a 100 base T4, it was designed to use this Cat3 cable or higher UTP. So this implementation it uses a 4 pairs of UTP for transmitting your 100 Mbps, and the encoding and the decoding is couldn't handle more than 25 megabaud. So the encoding over here, it is use what 8B by 60. That is 8 data elements are encoded as a 6 signal elements. So as we already discussed these fast Ethernet implementations, and this is the summary of fast Ethernet implementations. So this is the media characteristic, number of wires, maximum length, block encoding, line encoding, and these are the 3 implementations that we already discussed. So have a quick look on this table. Now talking about a gigabit Ethernet. Now the need for even higher data rate, it resulted in the design of gigabit Ethernet protocol, that is 1000 Mbps or 1 Gbps. This IEEE committee, it calls it as a standard 802.3Z. So what were the goals of this gigabit Ethernet? To upgrade the data rate to 1 Gbps, make it, compatible with your standard or fast Ethernet, keeping the same physical address, that is 48-bit address, and using the same frame format, then keeping the same minimum and maximum frame lengths, and support auto negotiation that we already discussed in your fast Ethernet. Now, guys, the main consideration in the evolution of Ethernet was to keep the MAC layer, untouched. And to achieve the data rate 1 Gbps, it is not much, no longer possible. So gigabit Ethernet, it used a two approach, that is a half duplex and full duplex. But almost all the implementation, they use full duplex. In full duplex mode, what is going to be happen, guys? There is a central switch, as we know, and which is connected to all computers as like this. This is your central switch, and it is connected to all stations like this one. And remember, in this mode, each input port, this is each input port, each, switch has a buffer over here in which, the data are stored until they are transmitted. And as you know, the switch, it is going to use the destination address of the frame and sends a frame. Suppose this station 1, it wants to communicate to station 2, then it is going to send its data through this switch, via this switch, to station 2. So this is your input port and this is your what? Output port. Hence, each destination, each station is connected to the switch. So there is no chance of collision, So the CSMA CD is not used over here. And since lack of collision it is there, it means what? The maximum length of this cable is not determined, by the collision detection process, but it is determined by the what? Signal attenuation in the cable, because it is using what? Full duplex for star topology. Whereas in half duplex mode, the difference is that instead of switch, we have to use what? Hub. And over there, you can use a CSMA CD concept there. Now, the topologies that we can use, to connect two or more stations. As we know, there are two stations, then we are going to use a point-to-point star topology, point-to-point connection. But if there are three or more stations, then we need to be connected in star topology with the hub or switch at the center. And these are the, another possible configuration which is used to connect several topologies, star topologies. So you can see that this is single star, this is another star. So it makes it two-star topology. And these are the hierarchy of these star topology. Now, the gigabit Ethernet implementation. So you can see it is going to use a 1000 base SX, that is your shortwave fiber, 1000 base LX, that is your long wave fiber, and this is a 100 base CX, which uses a STP, and this is a 1000 base T, which uses what? Cat5 twisted pair cable. And this 1000 base T, it was designed in response to those users who had already installed the wiring for other purposes, such as your telephone services or fast Ethernet purpose. And this is the encoding, and decoding schemes implementation. You can see on the screen that there are, the 4 implementations are there. And gigabit Ethernet can't use, the Manchester encoding, because it involves a very high bandwidth. It approximate, required 2 gigabaud. Hence, the 2-wire implementations, they use an NRZ scheme. But as you know, this NRZ scheme, it is not self-synchronous. So for that purpose, in order to overcome this problem, we use what? 8B by TB block encoding scheme. So, due to which it results in a data rate of what 1.25 Gbps, and then it is has been fed to this encoder. Now, in this four-wire implementations, it is not possible to have two wires for input and two wires for output. So each wire would need to carry 500 Mbps data rate, which is going to exceed the capacity of this Cat5 UTP cable. And for that purpose, we are going to use this 4D PAM5 encoding system over here, which is going to reduce the what bandwidth. And all four wires are involved in both this input and output, and each wire it is going to carry 250 Mbps, which is the range of your Cat5 cable. This is the summary of your gigabit Ethernet implementations. So let's have a just quick look. Now, talking about a 10 gigabit Ethernet implementations, basically there is advance in that Ethernet technology in order to use in metropolitan area. So idea is to extend the technology, the data rate and the coverage distance, so that the Ethernet it can be used for LAN and MAN. So the IEEE committee created a 10 gigabit Ethernet and called it was 802.3 AE, that is 802.3 AE. And the goals of this, the 10 gigabit Ethernet was same by to upgrading the data to 10 Gbps, but keeping the frame size, frame format constant, same, so that now interconnections of LAN, MAN and WAN it is possible. So you can see this implementation, that is 10 gigabase S, which is a shortwave 850 nanometer multimode. Maximum length it is of 100 meter cable, and the number of wires two over there. And second, it is your 10 G base L, that is use a long wave 1310 nanometer, and it approximate covers a range for this 10 kilometer for single mode. Similarly, 10 G base E, it is also for single mode, which has a 1550 nanometer, and it is going to cover a distance approximately 40 kilometer. And all these implementation it use a number of wires too. Now let's talk about the Ethernet IEEE 802.4 after 802.3. So IEEE 802.4 standard, it is going to specify the token bus media access control method, and it is one of the two token passing access methods. IEEE 802.4 is based on physical bus or tree topology, and the token bus approach it requires a station to have what possession of a token in order to transmit, and then this token it is passed from station to station in logical ring, and it is highly reliable for cable television equipments, and it can handle shorter frames. It supports a priorities and hence suitable for real-time traffic. Also has excellent throughput and efficiency at a high load. Now talking about Ethernet IEEE 802.5, the last topic of this unit. It is the second of the token passing access control methods. It is token ring. It is the most commonly used in a network structure which follows both logical and physical ring topology. And the right to transmit is controlled by, of course, by possession of your token. And again, it is highly reliable for cable television equipment, and it also uses point-to-point connections and transmission, any transmission media, it can be used. And the use of wire centers, make the token ring the only LAN that can detect and eliminate cable failures automatically. And very short and very large frames transmission both are possible, and the throughput and efficiency are excellent. This is the diagram for your 802.5 token ring LAN. So summary of our today's lecture. Today we have seen fast Ethernet. What are the different implementation in fast Ethernet? Then we have seen gigabit Ethernet. And the goals of all these Ethernet implementations for gigabit or 10 gigabit Ethernet, that is to keep MAC layer untouched, so that the frame size maximum and minimum size frame structure, we are not going to change that one. Just we are going to increase the data rate by means of different kinds of cables, fiber cables, or Cat3, Cat5 cables. Then different encoding system we use in order to make it compatible to handle such high data rates. This is the assignment. Please note down this assignment, and you have to submit this assignment to my mail shared on the screen. So thank you very much, students, for today's lecture.